Good day. We're talking about formulas today. Let's take a look. Just a few notes for you. I like to think about formulas as kind of like a math GPS. You know, it tells you directions. If you follow those directions, you'll get to the answer. You'll get to where you want to get to. The rest of the notes are pretty self-explanatory. So take a chance, or take a moment rather, to copy some of those notes down. Maybe pause it, and we're going to move on in just a second. And we're going to move on. Just some examples of some of the formulas that you'll have contact with in this unit. We talk a lot about circumference and area of circles. We talk about area, basic area, triangles, which is not on there, but we'll get to it. Rectangles as well. But we talk a lot also about three-dimensional figures, rectangular prisms in particular, and how the volume and surface area can be calculated using those basic dimensions that we can find either by measurement or by just looking at a figure that has given measures. So we'll take a look at some of those now. And this video is mainly example driven, so there's not too much fun artistry and theatrics. Let's take a look at some examples and maybe skip through some. I'll show you guys all the examples and you can try them out yourself. And as a matter of fact, I'll do that now. So if you want to take a quick snapshot by pausing and working on some on your own, please feel free. And I'll show you those just for a second. 1, 2, 3, and we'll take a look at one basic example. You see an example number 1 here. You're given a diameter of 12 centimeters. And you'll notice that I've already written the correct formula. And I pulled the formulas off of the formula cards that we use in class that you'll also see in your agenda books and also in your content review notes books that you receive every marking period. They're also located in every test that we take. Believe it or not, you may have skipped through it a couple times and not even realized it. So we're going to use these formulas and solve a few examples. And like I said, if you want to solve your own, if you've already solved your own, the key will be coming up in a little bit, so you can take a look at that. So I got 2 examples here to show you. Try to center those up for you. And we have a diameter of 12 centimeters, and we have an example with a radius of 8 millimeters. And you notice that I have only one formula written here, but I have 2 possible formulas written here and here. The main reason for this is because with a radius of 8 millimeters, we can use this, but it might take us an extra math step. If I use this formula, I can plug it in directly into C equals 2 pi r, 2 times pi times radius, and I can just do my math directly from there. The value of pi is always 3.14. And that's also on our formula sheet, so that kind of gives us an advantage. We don't have to memorize that, even though by the time we're done with the unit, we pretty much already have it memorized. And it's a matter of simply plugging in what is known about the problem. If I know the diameter is 12 centimeters, I can directly translate that from D to 12. I'm basically just rewriting the problem with the numbers that I need and finding my answer. And there's my solution for that. Okay, calculators are by and large okay for this, but I'm asking for 3 things to be known. I want to know what formula you used. I want to know what work you created as a result of that formula. And also I want to know the answer. So if I know all 3 of those things, I'm okay with a calculator being used. And if you're not going to use a calculator, that's fine as well. It might be a good idea to write your work somewhere in the margin. That way we can go back to it if we need to. We can see if there's a math error. And if we use a calculator, at the very least I need to see what you put in a calculator, and that's the reason for this step. Just to get down to this example right here, choose whatever formula you feel is most appropriate. My preference is to always use this formula. I'd rather always use the same formula rather than have to pick between the 2. But this is a perfectly good formula as well. If I were to use this formula, I would plug in my 8 millimeters as my radius and plug it in for my r. And then I would simply solve my problem. 2 times 3.14 for the pi times the 8 millimeters. And I would find my answer. I like this one a little better. So I'm going to follow that one. Why did I put 16 there? Why didn't I put 8? Well, if you answered that another 8 millimeters would make a diameter, then you'd be correct, and that's exactly why I put that there. And my answer will be 50 and 24 hundredths millimeters. If you're curious, I can solve this quickly for you. This would basically be the same exact thing. It just shows the step a little differently. You might realize that there's a 16 here and there's a 2 times 8 here. They're both equivalent. So the answer will be the same. I lift my units off, so I'll put my units on there. Can't see that? There you go. And if we backtrack down a little bit, we see that we have an area question, and I want to solve just one area question, and then we're going to leave the other one to your imagination, let you solve that yourself. We have our area formula. Area equals pi times radius squared. Another way of stating this is radius times radius. You'll notice that I have an example that has a 20 kilometer diameter. If I have a 20 kilometer diameter, how is that different from this? Remember, this is a radius and this is a diameter. We have different units there. So I need to turn this diameter into a radius. And you'll see that I kind of blew up the problem a little bit because I wanted you to see that 10 is my radius, and 10 squared is another way of saying 10 times 10, hence that value. When I multiply 10 times 10, I'm obviously going to get 100, so I'll show you that, and then I'll show my answer. 3.14 times 100 is going to be 314, and it's going to be kilometers squared. This is an area value, so we're going to use square units, as we always do. Okay, I'm going to change gears here a little bit, and I know this is going to be a little bit of a longer video than usual because we have a lot of things to cover in one small unit. But I want to show you some very basic stuff. Area of a rectangle, for instance. We have area equals length times width. We have 7 times 12. We have a wide side of 7 feet. We have a long side of 12 feet. And I'll basically just plug in my numbers. 12 times 7. Area equals 84 feet squared. Okay, if you want to try these yourselves, you can always rewind, pause it, solve them yourself, and then you're going to see them solved for you, basically correcting your work if you need the correction. Any explanation too. What I left off on here, actually, I'm going to put it right here, is a problem involving the area of a triangle. There's a right triangle for you. And I'm going to call this 5A because I didn't put this on there before. So I'm going to give this some characteristics here. I'll show you a little bit closer here. And I'm going to give this a base because the bottom of our triangle, which is opposite to the top vertex, is going to be, let's call that 12 feet. Feet again, it's okay. And we'll call this 20 feet. Alright, so I have a base measure, I have a height measure, and let's just say I give it this too. So I'm going to call the hypotenuse, which is this leg right here, I'm going to call that 24 feet. Which two numbers do I need in order to fulfill the formula? Okay, according to this formula, I need a base measure and I need a height measure. So I'm going to need base, I'm going to need height. I don't need this because that's an extra piece of data. It's not going to help me with my formula. So I have 1/2 times 12 times 20, and I can solve that pretty easily. I like to solve the hard part first and then just use the half at the end, and I'll show you why in just a second. 12 times 20 is going to be 240. And what I like to tell people is this: base times height, split it in half. Base times height, split it in half. Base times height, split it in half. And if you think of it that way, half of 240 is pretty easy to figure out. You could say half of 24 and then tack on the 0. Half of 240 is going to be 120. My units are feet. I'm going to call it square feet because this is a two-dimensional figure. It's a plane figure. I want to call it little 2, and I want to show my answer like that. So my answer is 120 feet squared. Alright, I'm going to skip over number 6 because that's pretty easy. And if you can tell me why in class, we'll have a little discussion about that. But I want to show you the last example. That's going to be using a three-dimensional figure such as a rectangular prism. Drawing isn't really all that great, but it does show all the formula components that are necessary to do both volume and surface area. And you'll notice that it has a well, you can call it a height, but it has all three dimensions. You can call this a height, you can call this a length, you can call this a width, and I have only those values for my formula. So I'm going to write volume equals, and I'm going to take all my numbers, I'm going to plug them in. So my length, I think I said, was 5. We'll use parentheses this time. Well, don't worry about that. We have a width of 3, and we have a height of 12. Now, depending on how your rectangular prism is oriented, the values might be named differently, but the numbers are still going to be the same. As long as you have 3 unique measurements for those 3 dimensions, you're okay. And this is just straight multiplication. Whenever you have nothing between the values, you are to assume that multiplication is taking place. So I'm going to multiply these 3 values. 5 times 3, just for reference, is 15. And then 15 times 12 can be 180, and it's going to be miles. But since I have a 3-dimensional figure and I'm calculating something in 3 dimensions, I want to call this cubic units. So I put a little 3 there in my answer, a little 3 power. Now, I don't do anything with the 3 mathematically. I'm just showing that as a function of the units that are necessary to explain the concept. So it's 180 miles cubed. I like to think about the volume as what goes inside the figure. I'll say inside solid figure. Okay, so what goes inside the solid figure? So the opposite of inside is outside. So surface area is the outside of it. I like to think about also volume as what's in it. Surface area is gift wrap, or what's outside it. Okay, if you were going to wrap this present, this box, what would you need? This formula can tell you exactly how much you need. So we have some variables here. We have L's and W's and H's, all the same values that are in our example. So I'm simply going to plug in, and it's going to look like this. It's looks a little bit busy, so I'm going to write just quickly here. Let's see, 2 times 5 times 3 plus 2 times, put parentheses around this, 2 times 5 times 12 plus 2 times 3 times 12. And that is a very, very busy looking problem. Let me simplify it for you. A little bit easier. How about this? A little bit easier. Okay, basically what this is asking for is the area of all 6 of these faces. If you can calculate the area of this face, then the back one should be congruent. If you're going to calculate the area of this bottom base, then the opposite one should be congruent. If I find the area of the front, or sorry, the left side, then the right side should be congruent to that. Picture doesn't really do a good job of it, but it should. And that's the reason why we have a formula such as this, 2LW. So let's say that the LW is supposed to be the base of it. So I have to have a top and a bottom. So the top is the LW, the bottom is the LW. There are 2 LWs. The LH would be the front and the back. So I have a front and I have a back. That's why I have 2 LHs. LH is the front, LH is the back. My WH is going to be my right and my left, because one of the WHs is my right and the other one is my left. So you can see why the formula is written the way it is. I'm finding basically the area of 2 faces, the area of 2 faces, the area of 2 faces, and now I have that whole gift wrap concept covered. I have all the faces covered, and I could put paper on all of them. So my total would be 222 miles squared. This is area. We're trying to find the area of all of these faces. So each of these faces is a 2-dimensional figure. And that's how we come up with an answer such as that. It's not a very difficult concept, but it is kind of work heavy because there's a lot of numbers that go into it, and there's a lot of operations. I think one good reminder might be to follow the order of operations when you're doing this, because we have to do all the multiplication first before we do the addition, and then we come out with our answer. This is a pretty long video, so I want you to take your time, pause often. If you need to go back and look at stuff, please feel free. Keep in mind that there are questions that we did not go over in there if you saw at the very beginning when these were blank. So please feel free to go back, solve stuff, look at answers, rewind back, look at how the work was done, and I'll also show you the key. So let me do that now. Here's a key to all the questions that were presented. Not all the ones that were done, but all the ones that were presented at least. Pause if you need to. And if you have any questions, please bring them to class. Let's talk about it. Let's figure it out. Let's practice using formulas. Let's practice using formulas, showing work, showing answers. And if you have any questions, let's bring them to class. Have a great day.